Welcome to Cambridge IGCSE Physics, Lesson 35.1, Positive and Negative Charges. This is core content for the Cambridge International General Certificate of Secondary Education Physics Syllabus 0625. Today we explore fundamental electrical concepts that form the foundation of all electrical phenomena. Electric charge is one of the most important properties in physics, governing everything from lightning to electronic devices. Understanding positive and negative charges is essential for your physics studies. Let's examine our learning objectives for today. By the end of this lesson, you'll be able to, first, state that there are positive and negative charges. This means recognizing that electric charge comes in two fundamental types. Second, no like charges repel each other. Like charges means charges of the same type, positive with positive or negative with negative. Third, no unlike charges attract each other. Unlike charges means opposite types, positive with negative. These objectives align with Cambridge IGCSE Assessment Objective 1, focusing on scientific knowledge and understanding. This is core content, essential for all students. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, electric charge, which means a fundamental property of matter that causes electrical effects. All electrical phenomena result from electric charge. Second, positive charge, which means the type of electric charge carried by protons in atomic nuclei. We represent positive charge with a plus symbol. Third, negative charge, which means the type of electric charge carried by electrons. We represent negative charge with a minus symbol. Fourth, repulsion, which means the force that pushes like charges apart from each other. Fifth, attraction, which means the force that pulls unlike charges toward each other. Understanding these terms precisely is crucial for physics success. Let's explore our first core concept. The fundamental principle states that matter contains two types of electric charge, positive and negative. This means every electrical phenomenon involves one or both charge types. Positive charge is carried by protons in atomic nuclei. We represent positive charge with a plus symbol. Protons cannot move freely in solid materials because they are bound in nuclei. Negative charge is carried by electrons around atomic nuclei. We represent negative charge with a minus symbol. Electrons can move freely in conducting materials, which is how electric current flows. The diagram illustrates these concepts. Notice the red circle represents positive charge, the blue circle represents negative charge, and the atom shows both types together. This principle is fundamental because all electrical effects result from these two charge types. Now we examine the experimental method. This follows Cambridge IGCSE standards for demonstrating charge interactions. The apparatus needed includes plastic rods for holding charge, silk cloth for creating charge by friction, acetate sheet as alternative charging material, and thread for suspending objects. The method consists of these steps. First, rub the plastic rod with silk cloth to transfer electrons and create charge. Second, bring the charged rod near a suspended charged object. Third, observe whether objects attract or repel. Safety is paramount. The hazards include static discharge and material damage from moisture. Therefore, you must work in dry conditions and handle materials gently. The diagram shows the setup. Notice how like charges repel. Both negative charges push apart. Unlike charges attract, negative and positive charges pull together. Let's work through our first example. The problem states, two charged objects are brought close together. Object A has positive charge, object B has negative charge. Describe the force between them. We are given object A carries positive charge represented by plus symbol. Object B carries negative charge represented by minus symbol. We need to find the type of force acting between these objects. Step 1. Identify the charge types. Object A is positive, object B is negative. Step 2. Apply the principle. We use the rule that unlike charges attract each other. Unlike means different types, positive and negative are different. Step 3. Determine force direction. The objects will pull toward each other. Step 4. State the answer. An attractive force acts between the objects, pulling them together. Example 2 applies the same principle to multiple charges. The problem is, predict interactions between three charged spheres. The data shows sphere X carries positive charge, sphere Y carries positive charge, sphere Z carries negative charge. Now we analyze systematically. First, consider X and Y interaction. Both are positive, so like charges repel. They push apart with repulsive force. Second, consider X and Z interaction. X is positive, Z is negative, so unlike charges attract, they pull together with attractive force. Third, consider Y and Z interaction. Y is positive, Z is negative, so unlike charges attract, they also pull together. Fourth, recognize all forces act simultaneously. The final motion depends on sphere positions and charge magnitudes. The diagram shows all three interactions with colored arrows indicating force directions. Advanced mathematical skills help solve complex charge problems systematically. Let's examine three key skills. First, identifying charge types correctly. Positive charges include protons in nuclei, objects that have lost electrons, and anything marked with plus symbol. Negative charges include electrons, objects that have gained extra electrons, and anything marked with minus symbol. Second, predicting forces between charges. When charges are the same type, positive with positive or negative with negative, they create repulsive forces that push apart. When charges are different types, positive with negative or negative with positive, they create attractive forces that pull together. Third, analyzing multiple charge systems. Consider each pair of charges separately using the basic rules. Then combine all effects to predict the overall motion of the system. Now practice what you've learned with these three questions. Question 1 is basic level. It asks, state the two types of electric charge and give their symbols. This tests your knowledge of fundamental charge types and standard notation. Question 2 is intermediate level. It states, two negatively charged rods are brought near each other. Describe and explain what happens. This requires you to apply the principle of charges repelling and explain the physics. Question 3 is advanced level. The question is, a positively charged sphere attracts a second sphere. What can you conclude about the charge on the second sphere? Explain your reasoning. This tests analytical thinking about charge interactions. For all questions, use proper scientific terminology and explain your reasoning clearly. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how charge interactions apply in practice. In technology, computer screens use charge attraction and repulsion to control electron beams that create images. Cathode ray tubes and modern displays rely on precise charge control. In industry, electrostatic precipitators clean factory emissions by using charge forces to remove particles from smoke. Charged plates attract oppositely charged pollutants. In medicine, defibrillators use controlled electrical charge to restart hearts during cardiac arrest. The charge creates electrical impulses that restore normal heart rhythm. In nature, lightning demonstrates massive charge interactions. When positive and negative charges separate in storm clouds, then discharge dramatically. These applications show why understanding charge matters for careers in electronics, power engineering, and medical technology. Let's review the solutions. For question 1, the answer is, the two types are positive charge with symbol plus and negative charge with symbol minus. This demonstrates knowledge of fundamental charge types. For question 2, we find the rods repel each other because charges repel. Both rods have negative charge, so they experience repulsive force pushing them apart. This shows application of the like charges repel principle. For question 3, the second sphere must have negative charge. Only unlike charges attract each other, so if the positive sphere attracts the second sphere must be negatively charged. This demonstrates analytical reasoning. Now, exam success tips. First, understand command words. State means give facts without explanation. Explain means provide reasons for your answer. Second, always include charge symbols, plus for positive, minus for negative. Third, apply the principles correctly, like charges repel, unlike charges attract. Fourth, use scientific language. Say repulsion and attraction rather than push and pull. Let's summarize today's lesson. The key points to remember are, first, there are two types of electric charge. Positive charge, represented by plus symbol, is carried by protons in atomic nuclei. Negative charge, represented by minus symbol, is carried by electrons around nuclei. Second, like charges repel each other. This means charges of the same type, positive with positive or negative with negative, create repulsive forces that push them apart. Third, unlike charges attract each other. This means charges of opposite types, positive with negative, create attractive forces that pull them together. These three concepts form the foundation for understanding all electrical phenomena. For further study, practice identifying charge interactions in different scenarios. Review the principles of electrostatic forces. The next lesson covers electric fields and electric potential, which builds on today's work by explaining how charges create forces at a distance. Ensure you understand charge interactions before moving forward.